Imagine this. A normal car engine, quiet and ordinary, suddenly turns into a fire-breathing rocket the moment you hit the gas. That's the magic of turbochargers. But how can a small device under the hood make this happen? Today, we'll reveal the science behind turbochargers and why they feel like rocket boosters. 1. What is a turbocharger? A turbocharger, often just called a turbo, is a remarkable device that can completely transform the performance of an engine without making it bigger. At its heart, a turbo is an air pump powered by something most engines waste every day: exhaust gases. Normally, when an engine burns fuel, it produces exhaust that leaves the car as hot gases. That energy just escapes into the atmosphere. A turbo cleverly captures this wasted energy to spin a turbine. That turbine is connected to a compressor, which forces extra air, full of oxygen, into the engine cylinders. Why does this matter? Because more oxygen in the cylinder means more fuel can be burned, and more fuel burned equals more power. Essentially, a turbo turns a small engine into a powerhouse. A turbocharged four-cylinder engine can match or even surpass the power of a naturally aspirated six-cylinder engine without adding extra weight. It's like giving your car a hidden rocket boost that only reveals itself when you push the pedal. 2. How turbochargers work. To understand turbochargers, it helps to break them down into two main components: the turbine and the compressor. Turbine side, exhaust gases leaving the engine are extremely hot and move at high speeds. Instead of letting this energy escape, the gases are directed into the turbine housing. The turbine wheel inside spins at insane speeds, sometimes over 150,000 revolutions per minute. That's faster than most sports cars' wheels ever spin on the road. Compressor side, the turbine is connected by a shaft to the compressor wheel. As the turbine spins, it drives the compressor, which draws in fresh air, compresses it, and forces it into the engine cylinders. This boosted air is denser, meaning each cylinder now gets more oxygen than it would naturally. The result? The engine can burn more fuel per cycle, generating significantly more power. The best part, it recycles energy that would otherwise be wasted. The exhaust, which normally just escapes as heat, becomes a source of raw power. Turbochargers aren't just about power, they're about efficiency. By using what will be wasted energy, they improve performance without requiring a larger, heavier engine. It's the ultimate engineering hack. 3. Turbo versus naturally aspirated engines. Naturally aspirated engines rely entirely on atmospheric pressure to fill their cylinders with air. There's only so much oxygen you can cram into a cylinder at normal pressure, which limits how much fuel you can burn and how much power you can make. Turbocharged engines break this limit. By forcing compressed air into the cylinders, a turbo allows more fuel to burn. A small 2.0-liter turbo engine can often produce as much power as a larger 3.5-liter naturally aspirated engine, and in some cases, even more. However, there are trade-offs. Turbo engines generate more heat, so they need stronger engine internals and better cooling systems. Modern turbo engines also use sophisticated electronics to manage air and fuel precisely. Despite these challenges, the payoff is enormous: explosive acceleration and efficiency that naturally aspirated engines simply can't match. That sudden surge when the turbo spools up feels almost like a rocket taking off, giving drivers a thrilling connection between engineering and adrenaline. 4. The physics behind the boost. At its core, a turbocharger works because of air compression and density. Engines need oxygen to burn fuel, and the more oxygen you have in the cylinder, the more fuel you can burn. More fuel burned means more power. Think of it like a balloon inside a room. If you squeeze a balloon, you force more air molecules into a smaller space, increasing the energy stored. That's what a turbo does with oxygen, compressing it and feeding it into the engine. The turbine spins using the engine's exhaust gas energy. The faster it spins, the more compressed air it pumps. Modern turbos can reach speeds of over 150,000 revolutions per minute, compressing air to extreme pressures. There's also a phenomenon called turbo lag. Unlike a naturally aspirated engine, which produces power immediately, a turbo takes a fraction of a second to spool up. Once it's spinning, though, the power surge is sudden and intense. This gives the car that thrilling rocket launch feeling, combining science and excitement in one pedal push. 5. Turbocharger myths and misconceptions. There are many misconceptions about turbochargers. One is that turbos are only for race cars. In reality, turbocharging is everywhere, from everyday sedans to SUVs and trucks. Another myth is that turbos are unreliable. Older designs could fail if abused, but modern turbos are built to withstand extreme heat and spin at incredible speed for hundreds of thousands of miles. They're extremely durable when maintained properly. Some also think turbo engines always consume more fuel. While it's true under aggressive driving, a turbo allows smaller engines to make more power efficiently, often improving fuel economy compared to larger naturally aspirated engines. In short, turbos are not exotic gadgets. They are practical, durable, and efficient devices that bring rocket-like power to ordinary engines. 6. Different types of turbochargers. Not all turbos are the same. Different designs exist for different purposes. Single turbo, the classic design with one turbine and compressor. Simple, cost-effective, and reliable. Twin turbo, two turbos work together. One small for low-speed response, one large for high-end power. Perfect for performance cars needing a wide power range. Variable geometry turbo, VGT adjustable turbine vanes optimize efficiency and reduce lag. Common in modern diesel engines. Electric turbo, uses an electric motor to spin the turbo instantly, eliminating lag and providing immediate boost. All types operate on the same principle, harnessing wasted exhaust energy to push more air into the engine. The choice depends on performance goals, engine size, and efficiency requirements. 7. Role life impact. Turbochargers have transformed automotive design. They allow smaller engines to generate more power, reducing weight and improving fuel efficiency. Sports cars, trucks, and everyday sedans all benefit. For enthusiasts, turbos are a playground. By increasing boost, upgrading intercoolers, and fine-tuning the engine, a standard turbo engine can turn into a rocket-like machine. That instant surge of power is unmatched by naturally aspirated engines. Beyond speed, turbos help manufacturers meet stricter fuel and emissions regulations without sacrificing performance. In short, turbocharging is a technological revolution, making cars more powerful, efficient, and exciting. Like, share, and subscribe for more.